Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tear, and this is my next video on my new feature on the Math Lovers book, which I've actually been running for about a month or so. And I'm not going to go through this series other than to say that you can buy it on Amazon.com. You can just look for either my name, David Tear, or the name of this series, the Math Lovers book, and it's available both in paperback and for Kindle. I think $30 a copy for paperback and $9 each for Kindle. I think they're a good buy. But in case you don't want to spend the money, you can watch my lessons for free on this channel. And like I said, I'm up to chapter 2, section 2.5, as a matter of fact. Chapter 2 is on numbers, and section 2.5 is on aliquot sequences, which include perfect, amicable, and sociable numbers. So today I'm going to talk about amicable numbers. So what are amicable numbers? They're also known as amicable pairs. They always come in pairs. And if you've been watching my last few videos, you saw what I said about aliquot sequences. That's just where you start with a given positive integer, and then you add up all the aliquot divisors of that number. In other words, all the divisors except for the number itself, and that becomes the next number in your system. And you keep going like that recursively. I guess kind of three or four different things can happen depending on the number you start with. Most numbers end up going to one, but there's special numbers that don't. There's special numbers that end up in a cycle. Um, the numbers that end up in a cycle of period one are known as perfect numbers, and I went over those, I think, in my last video. And they're very rare. Perfect numbers are very rare. As a matter of fact, there's only 52 known perfect numbers, and they all have a particular form. They're all very closely related to Mersenne primes. So there's 52 known Mersenne primes. Those are just primes that are one less than a power of 2, of which only 52 are known. And from each of those, we can easily construct a perfect number. So we know 52 perfect numbers as well. But amicable pairs are just with a perfect number, the period is 1. With an amicable pair, the period is 2. And what that means is you start with one number in your pair, and the smallest, I might as well tell you right now, the smallest amicable number is 220. And if you add up the aliquot divisors of 220, that is all the divisors except for 220 itself, you get 284. Turns out 220 has a fair number of divisors, and it's an abundant number, which means that its aliquot sum is bigger than the number. So, but then if you do the same thing with 284, it turns out that you get 220. The sum of the aliquot divisors of 284 is equal to 220, and 284 doesn't have that many divisors. It's 2 squared times 71. I think it has a total of just 6 divisors, and if you add all of them except for 284 itself, you get 220. So 284 is a deficient number, but you get back to where you started. It just takes 2 steps to do that instead of just one. And it turns out amicable numbers are kind of rare too, but they're not anywhere nearly as rare as perfect numbers. As a matter of fact, I think there's already over 1 billion known amicable pairs. I mean, computer sciences have been looking for them for a long time, and it was hard to find them at first. I'm gonna show you a little table here. These are all the amicable pairs up to 10,000, and I think this is kind of an interesting list because the last one was discovered in 1964. This actually required a computer. So the first 12 amicable pairs were all found by hand. And I think those are the only ones that were ever found by hand, if I'm not mistaken. And you can see the years on these are all before the computer age. I guess the most recent, besides the last one, was 1939. That was a guy named Brown who discovered the first odd amicable pair. Unlike perfect numbers, there are odd amicable numbers. So there's odd pairs as well as even pairs, although most amicable pairs are even. And they're both even. They're either both even or they're both odd. What's not known yet, although I think that most mathematicians suspect that there are no amicable pairs where one of the numbers is even and the other one's odd. This is still an open problem in whether there exists an amicable pair where the numbers in the pair have opposite parity. One's even and one's odd. Nobody's found such a pair like that, even though we found over 1 billion amicable pairs. But it hasn't been proven that they don't exist either. But as you can see, there are odd, and there's only one amicable. Well, actually, I think there's a couple, uh, or three. Yeah, so I guess the odd ones aren't so uncommon. There's three. There's 13 in total on this list, by the way. And I kind of like this list. I even tell you why I like this list. About maybe 30, 40 years ago, I had a book by Scientific American. It was an old book. I think they're still running. Scientific American is a very popular math and science magazine. They used to have a column there called mathematical games run by a very famous mathematician named Martin Gardner. He ran that column for about 25 years. And I think he ran a column probably sometime in the 1960s. I think it was like 1965, probably the year right after Rolf discovered the last of these. He had a column on amicable pairs, and it got kind of what's the word compiled into a little booklet, which I used to have. And I remember seeing this table in the booklet, and I think the booklet was from 1965, so it was brand new. And at that time, in 1965, there were only 13 known amicable pairs. The biggest one that was known was the last one on this list, which wasn't the numbers in this amicable pair are not even 100,000. But these were all the known amicable pairs up to 100,000. I think it was already known that there were no other ones, by the way, that this was a comprehensive list. But they're like I've actually calculated some amicable pairs. I remember when in the 80s when I had my IBM PC just for fun, I decided to calculate all the amicable pairs up to 1 million. They'd already been known, but I did it myself and I found all 42 amicable pairs up to 1 million. And I guess I could have gone higher if I wanted to. It took a long time. This was an old PC that was pretty slow. I mean, now I think with C++, I could probably write a program that calculate all the amicable pairs up to billion, and it might take a minute or two, but it's not a hard thing to calculate. And I think all the amicable pairs are known up to something like 10 to the 20th, some huge bound. And I think it's believed that there's infinitely many amicable pairs, although nobody's proven this. Just like nobody's proven that there's infinitely many perfect numbers, although I think most mathematicians believe there are, even though those are much rarer than amicable pairs. I mean, there's a pretty good, heuristics on the density of these things, and whereas perfect numbers have a very, very low density, which I'm not even going to try to say what it is. It's less than the natural logarithm. It's a lot. I think it's something like the natural log of the natural log, which is a very slowly growing function. I mean, log is slow growing already, but amicable pairs seem to grow about like the cube root. I think they seem to obey a power law. This has never been proven because we don't even know that there's infinitely many. But it seems like the number of amicable pairs up to some bound n is big O of something like the cube root of n, or a power that's close to the cube root, something like that. This seems to obey that law because there's 13 amicable pairs up to 100,000. There's 42 up to, 1 million. I don't know what it is up to 10 million. I've actually seen tables on this. You can look up tables on how many amicable pairs are up to given bounds, and there's a lot of them. You guys might want to enjoy looking for some yourself. So anyway, that concludes my video for today on amicable pairs. And by the way, I have a longer video just about amicable pairs. Some of what I'm talking about is a duplicate of some other videos on this channel. So you might want to look for my video on amicable pairs. It's a little bit more comprehensive than this one. This just goes through what I talk about in my Math Lovers book. But anyway, that completes my video for tonight on amicable pairs. Thank you for watching. Long live math, and I'll see you guys next time. Bye.